As a company, we've started looking at the circular economy about 2 years ago, and it's really interesting what that concept could mean. As an industry, we really face quite a few challenges. The construction industry produces a lot of waste, and we need to rethink what that means really for the sustainability and the future of our industry. And thinking about waste and materials in a different way and finding circular ways to use things like steel, wood and other construction materials, I think is really, really critical. In particular in the context of some of the big trends that we're facing, urbanization, climate change, resource shortages, they all put pressure on our industry to really innovate and find new ways to deliver the spaces and places and infrastructure that we will need in the future. It's much more about collaboration, finding ways to work together, finding common ways to create value out of materials and spaces. So the circular economy is really about rethinking how the entire industry works along the supply chain.
At the beginning, we wanted to build something that would respond to the waste crisis in London through construction and through domestic use. At the same time, we had lots of conversations with colleagues about the circular economy, and we put those two things together and thought, what would it mean if we built a building in accordance with the principles of the circular economy? So we took lots of components from all of the suppliers in the construction industry, put them together to make this building, the idea being that we would then be able to take them apart and give them all back to the suppliers. We've collaborated with suppliers, with BAM, with construction firms to put this together, and now we're learning about how we put these things back into the supply chain, and I think that's going to be an ongoing conversation. We've had so much interest in this. We've had a fantastic collaboration with lots of people, but in particular Frenner and Reifer have really helped us by putting this together for us, and they're going to take it apart, and they've really joined in the process with us.
In terms of structure, we began quite quickly in focusing on particular materials, and steel was one material we were very interested in because the steel industry has been thinking quite hard about circular economy, partly because steel is not seen as a sustainable material. And what we wanted was a structure that could be deconstructed and reused, not just downcycled. And we worked quite hard with ArcelorMittal in terms of detailing and availability of material to make sure that this was truly circular. We spoke with ArcelorMittal about whether they could supply the steel, and one of the things we did with the building was we worked to what they could get for us and what was available, and therefore we weren't using new steel, and we actually adjusted the size of the building slightly to deal with that. We also talked to them about best forms of connections that then could make the steel very reusable afterwards, including things such as the connections to cladding, not making holes in the steelwork, leaving them as kind of unmarked as possible.
My role as structural engineer on this circular building was to develop lots of ideas. Firstly, for the structural frame. So we developed a steel concept, which was then clad in a very unique facade panelization idea, where we've used push-fit connections and then clamps called limb adapters to connect them to the steel frame. This has all come together as layering the building, which has actually kind of developed the circular idea of being able to deconstruct the building.
My role within the circular economy building was these panels, the panels that formed the whole building. So basically we started with a pitched roof house, and we decided to go through a very simple detailing of the wiki panels. Having the panels cut precisely, following a computational process, you eliminate all the possible waste that you can get on site. So that's very important, very key for this whole ideology. And once they're brought to site, just to bring them up, it's a very straightforward process. So again, it cuts the time, becomes more efficient, and it's, I guess, almost like foolproof because it becomes a kit and it gives you more flexibility in terms of what you want to do. And it's just finding the rationale behind how you put a building together.
I was involved in the whole process on site, starting from the first day setting up the site and all the way through to the end. And it was really interesting to see the construction detailing forming into reality on site. It's very easy to revert back to common practice, to take the easy way out. But we made a conscious decision at every process when we had a problem that we encountered to try to resolve it as much as we could in a circular way, so that we were being true to the ethos of the project and making sure that whatever we put in, we were able to take back out again.
Firstly, to discuss the insulation, we really toyed with the different types of insulation. Rockwool we know is a good, sustainable insulation type, but it does lead us to certain thicknesses of wall. We actually approached Procter Group, who make an aerogel blanket. Actually, they came back with this recycled version of their aerogel blanket, which uses all the waste products they've been collecting for years. So it performs not as well as their kind of standard aerogel blanket, but it does perform better than the likes of Rockwool. The other kind of key aspect for buildings other than the insulation is the water tightness. So actually we found Fatro, who have a membrane which is mechanically fixed, so therefore it does allow us to disassemble it. The other thing which is really interesting about it is that they have their own recycling plant, so they can take old membrane and they can turn it back into new membrane.
Key aspect of the circular economy is that when materials are taken out of a building at its end of life, they can then be reused. But in order to reuse those materials and incorporate them in new designs, you need to know a few bits of key information about them. Sort of things as simple as just the size and weight of the components, but also their design information, the specifications that they were made to, these kinds of things. Each of the materials in the building is tagged with a QR code. You can access that information when you're inside the building through the bespoke website, which sets up sort of the reasons why we engaged in this in the first place, and then digs down into the levels of detail on the structure, on the skin and the other parts of the building, and then further to another level of detail on specific components and materials that we have used, which would hopefully allow maintenance and replacement of those materials through the life of the building easier, but also at the end of life allow those materials to be made available to other buildings and other designs.
Designing systems for the circular building was quite challenging because especially services, they come in lots of components. Manufacturers could potentially take the onus of designing systems which are circular, and this is one of the strategies that we took. For instance, the battery system is water-based, and I think it's the only cradle-to-cradle certified battery system in the world. We wanted to have energy storage in the building because it ties with the idea of decentralized energy storage that can actually smoothen out the peaks in the electricity network. There are other strategies that we took on board in the prototype to add more circularity, and usually when we kind of hit a barrier, we try to be creative about it. So with the lighting, for instance, the fixings are all magnetic, so that lighting can be easily removed. It can have also onboard electronics to provide controls, so minimizing actually the amount of little boxes that you have to distribute in order to achieve a more granular control.
My responsibility for the prototype was to design the ventilation system. For this prototype, we have designed and built a 3D printed and laser cut mechanical ventilation system with heat recovery. This unit provides fresh air to the indoor space, allowing for a better environment while reducing the energy consumption. All the internal components have been 3D printed by using 90% PET recycled filament, and all the software and hardware are open source. This was a good opportunity for us to test those digital manufacturing technologies within the building services.
Throughout the process of looking at the interior aspects of the circular building, we were surprised to find that there are actually companies out there that are addressing the way we approach interior fit out in a circular way. So looking at using recycled material content, but not only that, but the way we use it in a fit out so that it can be reused after that. One of the most interesting things I found through the project is the take-back scheme. So companies are really instigating relationships within our supply chain, and it encourages suppliers to have a vested interest to take back material and use it again and again.
I think one of the most rewarding aspects is actually to build the physical prototype and see people interact with it and let them smell and touch and feel how something like the idea of the circular economy can actually, in a very simple way, turn into a really pleasant building and environment. It's incredibly valuable that we build things like this to show people that it is a possible future. I think one of the most important things we learned is that the idea of the circular economy forces you to collaborate much earlier in the design process, both with our colleagues and also with our clients and the design chain to produce something that's tangible.
When we began the exercise here, we, as designers, expect a certain degree of challenge and a certain process that we would normally go through. This building, interestingly, has challenged us in different ways, We asked questions of ourselves, we asked questions of the supply chain. The primary one being, can we build a building within the framework of the circular economy philosophies? And this in itself would have been a first for, I think, the industry, and certainly the first for our team. Mostly the answer to that was positive. We did have certain wobbles along the way, and as you would expect, our design process morphed along the way. The building began in a certain shape and a certain volume. As we learnt more about what was available to us and what the market could do for us, we needed to adapt and flex. And this, for us, created certain challenges in a very non-linear process. The primary difference being that we needed to be more mentally agile. We needed to say to ourselves, well, we can't actually find a circular product, so we needed to go out and search and explore, and that in itself then changed what we then believed to be standard detailing that we were going to utilise. So it's been a huge learning experience.